Hi, welcome to the ninth session of Algebra 1. My name is Shobhi. So today I'm going to take a live session for this course. Okay, so today first we shall start with assignment 7 solution because it's an order. So let's start the assignment 7. Then if time permits, we will roll back to other assignments. Also, after finishing the assignment, we will go to if you have any doubt, you can ask me in written or you can let me stop and just ask a question. Okay? The point is that this session is meant for the problem solving doubt theory. So please use the sessions. Okay. So okay, so let's start with assignment 7. Assignment 7. Okay. So for the first question. So I can add the question first. So first question is the following. Given that consider the ring of formal power series, the ring is Z6 double bracket X with the infinite polynomial ring over Z6 and a polynomial P is equal to A0 A1X dot 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 is given to be an unit in the ring Z6 double bracket X. So the question is then what are the possible values of H0? Okay, this is the question. Okay. So how to solve it? We have only the given information that the given polynomial it is only given that the given polynomial is units. Okay, so we need to use some of this fact. So how to solve this? So using the information only the given polynomial unit, we need to solve. So assume that P inverse is equal to Q, okay, and let Q is equal to B0 B1 dot dot dot. That is PQ is equal to 1. So now what is PQ? A0 A1X A2X square plus dot dot dot, and Q is B0 B1X B2X square plus dot dot equal to 1. So this implies what? A0 B0 plus X A0 B1 B0 E1 plus dot dot is equal to 1. So the comparing coefficients, this implies A0 B0 equal to 1. Only we are getting this by comparing coefficients. Okay. So since A0 B0 is 1, so this implies what? B0 is, so this implies what? A0 is the unit, right? So that is A0 is the unit. Now in Z6, and do note that A0 belongs to Z6. So what are the units in Z6? All those n's, so the GCD n and 6 are 1. So 1. So what are the all possible values of n? Can be equal to 1 or 5. Okay, so a0 can be either 1 or 5. So there is a process of solving this problem. So let me repeat this argument again. So given a polynomial, it is only given to be unique. Okay, now we need to check how to, what are the possible values of a0. So for this, what we are doing, so what are the possible a0s? For that, what we are doing, this is given that p is an unit. Okay, so there exists some q such that p into equal to 1, right? So this implies that then we are multiplying this to polynomials, we get a0 plus x into something plus dot dot dot, which is equal to 1. So by comparing coefficients, we get that a0 b0 is equal to 1. So this implies what? This implies a0 is an unit and a0 belongs to z6. So we need to check how many units, what are the units in z6. So what are the units z6? Units z6 are either n equal to 1 or n equal to 5. So that's why 1 or 5. Okay, so this is the technique of solving this problem. Okay, what are the next? So next problem is the given as follows. So given that let summation n bn is inverse of 1 minus x square in q third bracket x. Okay, then the question is, then what is the value of f5? Let me repeat. It is given that summation a n x is inverse of 1 minus x square q third double bracket x. Then what is the value of f5? So how to do this? So what is the value of f5? So we need to use this given information, that is, so 1 minus x square into a0 a1x a2x square a3x cube a4x4 a5x5, sorry, plus this is given to be 1. Okay, so now we need to somehow calculate the value of this. So how to do this? Just multiply. So first it is h0, coefficient of 1. So this is equal to 1. Now what is the coefficient of x? The coefficient of x is what? The coefficient of x is a1 minus is equal to 0. Now coefficient of x square, how what? So this is a2 minus a1 minus is equal to 0. Okay. Coefficient of x cube is what? So a3 minus a2 minus a1 equal to 0. Coefficient of x4 is what? a4 minus a3 minus a2 equal to 0. Coefficient of x5 is equal to what? a5 minus a4 minus a3 equal to 0, right? Okay. Now what we can do? Here a is equal to 1. So this and this two equation gives a1 is equal to 1. Okay. Now we know a0 and a1 here. So this implies a2 is equal to a0 plus a1. This is equal to what? This is equal to a0 a1 both are equal to 1. So 2. B is equal to a3 is equal to a2 plus a1. a2 is equal to 2, a1 is equal to 1. 2 plus 1 is equal to 3. a4 is equal to a3 plus a2. a3 is equal to 3. 3, a2 is equal to 2. It is 5. a5 is equal to a4 plus a3. a4 is equal to 5, a3 is equal to 3. So it is 8. So answer a4 is equal to 8. Hi, can you hear me?
Yes, sir.
Yes.
Good evening, sir.
Yeah. Can you see the screen? Can you see the screen? Can you please confirm? Can you please confirm? Can you see the screen? Okay, I have got some screen. Okay. So okay. So today we're starting with assignment 7. Okay. Okay. So before telling me, just confirm me one thing. It's the assignment 7 solution has already been released. Am I right? Hello. Can you please confirm that assignment 7 solution has already been released? Am I right? Are you there?
Yes, sir. Release it, sir.
Okay. 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 So first today we shall first start with the assignment 7 solution. Okay. Okay. So before going through this, tell me one thing. Do you have any doubt or any confusion or anything related to last live session or anything related to search lecture? If you have any doubt, please ask. Okay. So first today we are going to finish the assignment 7. Then if time permits, then we will go to other assignments and you can ask. Then also you can go through problems from other books or concepts. Okay. So the first problem is given us as follows. One second. Okay, so first problem given as follows. So consider the ring of formal power series Z6 double bracket X, and it's given that a polynomial, this polynomial is given to a unit in Z6 double bracket X. Okay. Now the question is, what are the possible values of H0? Okay. So the way of solving is that you need to use the information that the given polynomial is unique. Okay. So since the given polynomial is unique, we assume that the inverse of p is q, and let q is of the form b0 b1x plus dot dot dot. So p into q is equal to 1, right? Now since p is equal to 1, so we can use this. We have this equation And in this equation, by comparing coefficients, we get that a0 b0 is equal to 1. So this implies what? A0 is a unit, but A0 is an element of Z6. In Z6, which elements are unique? Those elements are unique whose GCD with 6 is 1. So either n equal to 1 or n equal to 5. So possible values of A0 is equal to 1 or 5. Okay. So this is the argument. Please go through the argument and let me know, do you have any doubt or any confusion? Please go through the argument, let me know, do you have any doubt or confusion?
জি, অনেকটা হয়ে গেছে। Hello, sir.
Yes, yes.
Sir, I have some medical issue. Then I am getting late.
Okay, okay, no problem. Okay.
Mm,
So firstly, today we have started the assignment 7. Okay.
mm,
After discussing assignment 7, this time we will go to solving the previous assignment. So we have started with assignment 7. So the first problem is the following. Okay, so before starting this, can you please let me know, do you have any confusion or doubt from the previous session, or else you can ask any doubt from the search lectures or search note. You can any doubt if you have. If you have any doubt, please ask. Okay. Also, today, okay. So the first problem is as follows. Uh, Consider the ring Z6 of formal power series Z6 double bracket X. Okay, formal power series. Then a polynomial P is equal to A0 A1X plus daughter is a unit. And given that a polynomial P in Z6 double bracket X is a unit, it is given to be unit. Now the question is, what are the possible values of A0 and the polynomial P is given by A0 plus A1X plus dot dot dot. Okay,
mm.
so
What is mean by double bracket? We have also acquainted with single bracket only.
uh, double bracket means polynomials, infinite polynomials.
Okay.
I mean, once again, like R double bracket X, R is a ring,
Mm,
is equal to A0, A1X, A2X square plus dot dot dot. It goes infinite.
mm,
Okay, it is not finite, it is finite. So that's the polynomial ring. That's the R double bracket X, and
okay.
known as the formal power series. Okay,
Mm,
so given that this polynomial is unit, now the question is, what are the possible values of A0? This is the question. Okay.
mm.
So first tell me, without looking at the screen, honestly, first tell how you solve this. Have you? I mean, yeah, this assignment has been answer has been released, so definitely you have solved this. I hope. So if yes, then please tell me how you have solved this problem without looking at the screen. I mean, without looking at the solution, please tell how you have solved this problem.
Mm.
Honestly speaking. I mean, did you solve this problem in the assignment? Don't hesitate.
No, no,
Okay.
no.
Okay. No issue. So look, that it is given that B is unit. Okay, so B inverse is equal to Q. We can assume, right?
Mm,
So and since B is a unit in Z6 double bracket X, so
mm,
Q will also belongs to Z6 double bracket X. That is, I mean, I mean this. I mean inverse will belong to that ring. That's the point. Okay.
mm,
Now PQ is equal to 1 being the inverse, sorry, unit.
mm,
So we have then, I mean, so we can multiply those two polynomials to get 1. Am I right?
mm. Yes, yes.
Now, so it's a just a polynomial multiplication, but infinite multiplication. That's it. That's the only difference. It's the infinite multiplication, but no need to worry. The thing is, right side is 1. So right side is constant term. So in the
mm,
left side, we need only to check the constant term because those coefficients of ax, x squared, x cubed, dot, 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 all are going to be 0 because right side is constant, right?
mm, mm,
So that's why in the left side, what are the constant term? Only a0, b0, right?
mm,
So, and right side is 1. So a0, b0 is equal to 1, correct?
mm.
So this implies what? A0 is a unit, right?
Yes.
And it belongs to Z6 because A0 is the I mean, it's the element. That's why.
Mm.
So in Z6, what are the units? Z6,
Only
uh,
co-prime element are.
correct. So only 1 or 5. So the only
Mm,
possibility of A0 is either 1 or 5. So this is the
mm,
process of solving this problem.
mm, mm,
You understand the way?
yes, yes.
Okay. So, okay. So, okay, the next problem is as follows. It is given that this infinite polynomial is inverse of this polynomial in q third bracket x. So it is given. Okay. Now
Mm,
the question is what is the value of a5? Look, the polynomial is given to be infinite polynomial. Okay. And
mm,
given that it is the inverse of some given polynomial, now we need to find what is the value of the coefficient e5. Okay. Now, uh, okay, so exactly in the same way the previous problem, here also is given to be inverse. So what you need to do? You need to multiply those two polynomials and it should be equal to 1. Then you need to
mm,
compare coefficients, right?
mm,
So only there will be constant term equal to 1 and the all coefficient x, x squared, x cubed, all those will be 0. So then after the calculation, we are getting f5 is equal to 8. Okay.
mm.
Now the point is that without looking into the screen, I mean, you understand how to solve this, am I right? Do you understand how to solve this?
Yes.
No, no. If you have any doubt, please ask.
Mm,
Don't hesitate. Okay. Without looking into the screen, you manually solve how to. I mean, what is the value of a5? You solve by yourself right now.
o- okay.
Sir, I think coefficients forms Fibonacci sequence form.
Sorry, can you please repeat?
Coefficient sequence forms Fibonacci sequence.
Fibonacci sequence is something other. This is not a Fibonacci sequence. Okay. This is not a Fibonacci sequence. I mean, you can tell only that some are going to cancel. That's only thing. I mean, but it's not the Fibonacci sequence. Okay. So, okay. So, Supratim, yeah. So, calculate the A5 right now. Take your time, but do the calculation. If you got stuck, please tell me. Are you able to get A5? Are you able to get A5? Are you able to get A5?
No, sir, trying.
Yeah, let's try.
Yes, sir, I understand.
Good. So Supratim, are you done with A5? Supratim, you got the A5?
Sir, on question, I am not seeing the solution you have done on the board. It is same. Hello.
Yes, yes, please tell.
It is seem to me that we need a pipe. So we it is sufficient that we find some equation in number 5, uh, and comparing the coefficient up to 5 with the left right hand side. I mean, coefficient of x is 0, coefficient of x square is 0, so on up to a4, x
Yes.
to the power 4 is 0.
Yes, yes, fine.
Yeah.
Okay.
Mm.
But at least by hands we should solve after. It's okay. Okay, so the next problem, does here exist a surjective?
Sir,
Yes.
so I have one doubt.
Yes.
Is there any difference between homomorphic and homomorphism?
Is there any? Difference.
Hom- Homomorphic, homomorphism. Both are same or different?
Okay. So, so suppose we know that A between A and B there is a homomorphism. Okay, right? But I mean homomorphic is basically nothing but uh, okay. So this is said to be homomorphism, and if A is said to be homomorphic with A. Okay. So moral of the story is image of a homomorphism is said to be homomorphic with the domain. Understand? It's a simple way.
On to homomorphic, subject to homomorphism should be homomorphic.
No, no, that's what I'm saying. If it is f of A is said to be homomorphic with A. That's all it is. If it is surjective, then a whole capital B is homomorphic to capital A. That's all. That's it. Okay.
So one more time explain please.
Right?
One more time explain. I can't catch.
Yes. Yes. So if A to B there is a homomorphism, then f of A, that is image of F, this image of F is said to be homomorphic with capital A. Understand? I mean, homomorphic is something which is the image of the domain. That is the homomorphic. Suppose B is said to be homomorphic with A, means there exists a homomorphism F from A to somewhere else, whose image is nothing but B. Understand?
Yes, sir.
So now the problem is that in the assignment, the question is: does there exist a surjective homomorphism from Q third bracket X to QX? Okay, this is the question. Does there is surjective homomorphism from Q third bracket X to QX? Think about it.
Sir, here Q third bracket X is the ring of finite polynomial whose coefficient are coming from Q.
Okay, so one hint can be as follows that Since it is a homomorphism, so one goes to one, right? Now try to use the fact that one will goes to one. At least one should goes to one. You can directly, you need to use this. Are you getting it? How to? Anybody solve this?
Sir, I have an idea. As subjective, left side is finite polynomial, finite degree polynomial, and
Yes.
right side is a power series. So if we take any element from Qx, then it should be mapped in a polynomial in Q double third bracket x, up to the up to which is the degree of the polynomial up to that coefficient. After that, all terms should be taken as zero.
Basically, your process is that you are choosing some integer and then you are sending the polynomial such that after, I mean, by truncating the polynomial after the integer, right?
Uh,
Okay, so first, why tell me why it is a homomorphism? Because while truncating, I mean, the problem might arise in a multiplication, right? A multiplication, the problem will arise actually. So that's why the truncation with technique will not work here. Okay. So any other argument? Think about it. Okay, so idea is as follows that okay, so first of all, sorry, sorry. Okay, so first of all, one goes to one. Okay, and so since one goes to one, so all n goes to n for all n belongs to k. This is not difficult. And basically all x goes to x for all x belongs to q. Okay, it is not difficult to check. Now, sorry, since it is given to be okay, so first of all, I mean, sorry, all y. Okay, so under the isomorphism, sorry, under this surjective homomorphism, every every element of q has an inverse image under this map. Okay, so q goes, so y goes to y. I mean, this map restricted to q is identity. Okay, let me write down clear first. Sorry. Now, since it's given to a surjective, so its x belongs to qx, right? So there must exist some gx belongs to q double bracket x such that uh, call it phi x equal to pi gx, right? Now what is g? Let g is equal to a0, a1x, a2x square plus dot dot dot. So phi is a homomorphism. So this will be a0 plus a1 phi x plus a2 phi of x square plus dot dot dot, right? So this is our x, correct? So now, hmm, okay, just wait. So we'll just go around. Okay, this way will not work, okay, because then no idea what to do. Okay, so another process of solving this is that, okay, do note one thing is that since q is the field, so qx is a PID. Okay, now what about q double bracket x? Is q double bracket x PID?
What was the question?
Okay, the question is that does there exist a surjective ring homomorphism from q third bracket x to q single bracket x? Any surjective ring homomorphism possible or not? That is the question. Okay, so for this we need to check properties of both the rings. Okay, which one have and which one doesn't have. So now qx is a PID. So what about q third bracket x?
Qx is a field. Qx the field also. That means PID also.
What what, what you have just said?
Qx. In fact, Qx is form field.
Qx qx not a field. I mean, what is the inverse of x? What is the inverse of x?
1 by x.
Q in Q third bracket x. What does it mean? What does it mean by 1 by x?
uh, 1 by x. Oh, huh.
The theorem is that if R is a field,
Then
then
Rx
Rx
is
is a field. Okay, that is the thing. So Q is a field, Qx is a PID. So the first question is, what about Q third bracket x? Q double bracket x. Is Q double bracket x PID?
sir. Double third bracket x can be considered m- whose coefficient come from
Yes.
q third bracket x.
No, I mean the point, I mean Q third bracket x, the spaces having polynomials, and polynomials goes infinitely. Okay, that is the specialty Q third bracket x. There is an infiniteness coming, but if you are considering it as a polynomial or single variable somehow, then it can't be infinite, right? You need to somehow come up with some infiniteness, right?
Okay.
Understand?
Hmm.
So what about Q third bracket? Is Q third bracket x PID? Sorry, double bracket x. Is it PID? So thing is, I mean, if in case you don't know this, let me tell you that this Q third bracket x is a PID as it is an uh, ED. Okay, equivalent domain. It's a fact. I mean, you can find it over any that Q any ring of corner power series is an PID since it is an ET. Okay, so this direction will not work because both are PID. Okay, so now one thing is that, so the another way is, I mean, the another way out of solving this problem is looking at the number of maximal ideals. Okay, so we have Q third bracket x and Q third, I mean, double third bracket x and Q single third bracket x. Okay, now observe that Q single third bracket x, it has infinite maximal ideals. Let me explain one thing. First question is why? Why Q third bracket is infinite maximal ideal? So Q third bracket x, if you consider this polymer Q third bracket x by ideal generic x minus c, it can be shown to be isomorphic to Q. Question is how? So Q third bracket x to Q, we have some map, and if taking fx goes to f of c, right? So it can be shown this map is a ring homomorphism and which is a surjective. Okay, and it also can be shown that kernel of P is the ideal generated by x minus c. So by first Phi-Esmond theorem, QC by x minus c isomorphic with Q. Okay, so this is the so that's why QX has infinitely many solutions. But claim is that Q third bracket X has unique maximal solution. Sorry, unique maximal ideal. Okay, the thing is that so first of all, in order to solve this problem, we need to compare some properties. Okay, the PIDness is not working because both are PID. Now we are looking in the number of maximal ideals of both the things. Okay, so the thing is Q third bracket X has infinitely many maximal ideals because by this argument given the right it can be shown that Q third bracket X by either geometry X minus C is isomorphic to Q. So this either geometry X minus C is a maximal ideal and QX. Okay. Now we are claiming that Q third bracket Q double bracket X has unique maximal ideal, namely the ideal generated by X. Okay. So if we can show this, then we are done. Am I right? Okay, just tell me one thing. Have you heard about local rings? Have you heard about local rings?
No.
Oh,
No, sir.
okay. Okay, the thing is that sir will definitely go with the local rings. I believe. So the thing is, it can be shown that Q third bracket X, it is a local ring. Okay, it's a separate theory. It's a separate portion actually. It is not a small thing. I thought you know this. That's so sorry. So anyway, the technique is that you need to consider the number of maximum ideas. Q third bracket X has infinitely many maximal ideas generated by either generated by X minus C because Q is a field, but Q single bracket X has only maximal ideal either generated by X. This is only maximal ideal. So that's why Q third bracket X to QX there is no surjective homomorphism possible. I mean, this is the overall idea.
Sir, what is the reason behind the infinite maximal ideal of the QX? It is shown that QX quotient by ideal generated minus X minus C isomorphic to Q. How this can assures about the infiniteness of the number of
Let
maximal ideal?
yes, let me explain. So, one second. So Qx by ideal general X minus C isomorphic to Q, right? Now Q is a field, correct?
Hmm.
So since the quotient is field, so the bottom ideal has to be maximal ideal, right?
Yes.
Correct. So X minus
Hmm.
C is a maximal ideal for any C, right?
Okay. Acha.
So that's why this is a maximal ideal. So I
Hmm.
mean, so that's the infinite maximal ideal.
Okay. Okay.
Yeah. Okay. So let me go to the next problem. So the question is that how many ring homomorphisms are there from Z4 to Z8? How many rings are there from Z4 to Z8? Think about it. you need to use the properties of weak homomorphisms related to order. Also need to use the what need to use first Raisman theorem. Using this, first try to solve this. If you are unable to solve, then I will solve it. Okay. Let's try to solve. Take your time. I shall be back after 2 3 minutes. So, are you able to solve this? Are you able to solve this?
Sir, is
Yeah.
it GCD of 4 and 8?
I mean, don't try to use some random theorem. Do it from the scratch. You are using some theorem, am I right? I mean, are you using some
Mhm.
theorem? Sorry, I mean, if you're using some theorem, don't use it. Do it from the scratch. I mean, there is
Okay.
no point using a theorem, right?
Okay, okay.
Yeah.
Only one thing, if you notice that only it is suffices to that unit of Z4. How many ways unit of Z4 are mapped to the Z8? That would be the number of.
Yes, yes, right, right.
Uh,
Yes. So basically, you need to go with only the order of one word, right? Because order of the one word are the only possible direction for this, correct? I mean, so it's a ring homomorphism. Ring homomorphism. So there are some properties related to order of elements, right? So try to use those. Or do we take any direction? Or do we take any direction? Okay, so the argument is as follows. One second, I'm actually back up some minutes. Okay. Oh, so the argument goes as follows. Okay, so let's F be the map from Z4 to Z8 be ring homomorphism. Okay, so f of 1 bar is equal to 1 bar, correct? And order of 1 bar in the image is equal to Z8. Okay, and it is also given that it is also known, so it's a ring homomorphism. So order of f of 1 bar divide order of 1 bar, and the right side order of 1 bar is equal to 4. So in Z8 we are getting that order of 1 bar divides both 4 and order of 1 bar divides both 8. So mm, I mean the thing is that uh, since the ring homomorphism, so f of 1 is equal to 1. Okay, it is assumed by definition. So we are getting in the on Z8 order of 1 bar is divisible by 4 by order of 1 bar is divisible by 8. Okay, so let me write down, let me explain the solution again because I also got messed up actually. Sorry. So okay, so order of 1 bar is 4 in Z4. Now since the ring homomorphism, so it is known that order of f 1 bar divide order of 1 bar in Z4, which is equal to 8, 4. But f of 1 bar is equal to 1 bar. So order of f of 1 bar is equal to 8. Okay. So this implies what? Order of 1 bar divides 4, but order of 1 bar is known to be 8, right? So 8 divides 4, it's a contradiction. So that's why there is no homomorphism from sending, I mean, there is no ring homomorphism. So this is the argument. Do you understand? Don't hesitate, please let me know.
Yes, yes.
Okay. So, So that's why there is no. So there exists. I mean, so how many ring homomorphisms are there? It is zero. There exists no ring homomorphism from here to here. That's the argument. Understand? Now, hmm. Okay. So now comes to the following question. Let R b is equal to z2x either generated by x cube plus 1. Okay. Now the question is then for which ideals below is the quotient ring or quotient ring is not clear. So R is given ring. Now the question is we are going to supply some ideas. Now we need to calculate for which of the ideal the quotient R by I is not trivial. Okay. First option is ideal generated by 1. Second option is ideal generated by x. Third option is ideal generated by x square. Fourth option is ideal generated by x plus 1. Okay. Think about it.
Sir, scroll down the page.
So R is given to be,
Okay, okay.
so you need to check by quotienting out through which ideal the given thing will be a non-trivial. I mean non-zero, that's all. Non-trivial, I mean non-zero or trivial. You need to check that. So first of all, you need to realize one thing that
Sir, question is not clear. What is mean to say?
uh, the ring R is given. Okay. Now there are some few ideas given. Okay. Now the question is that by quotienting out which ideal, I mean call these ideals to be I. Okay. Now question is that for which I R by I is non-trivial. For which I this R by I is non-trivial. This is the question. Do you understand now?
Yes, yes.
Yeah. So this is the question. Do you understand? So the thing is that first of all you need to understand the R by Y. Sorry, I mean suppose for any ideal J, I by J makes sense only if J is contained in I, right? Because all this ideal is under the quotient R by I, right? Everything is under the quotient R by I. So you need to understand which ideal contain xq plus 1. So this is the first thing you need to observe. Do you understand what I'm trying to say?
Yes, please repeat.
Get it?
Please repeat. I
Yes.
don't understand.
Sure. The thing is that all those ideal I are belongs to R by, I mean belongs to the quotient. All the ideals are in the quotient ring Z2 x cube plus 1. Okay, right. So first of all, the thing is the quotient ideal I by J makes sense when J contained inside I. So the point is that within this option 1, 2, 3, 4, all of the, I mean first need to understand which ideal contains x cube plus 1. This is the first thing you need to observe. Do you understand what I'm trying to say?
Yes, yes.
Yeah.
Is it X?
Sorry.
Is it ideal generated by X?
No, I mean, first of all, you need to, I mean, does x cube plus 1 is contained inside either generator or IO? Is it possible? Is it possible? I mean, so you need to basically think, is it possible to write x cube plus 1 is equal to x into some polynomial gx? Is it possible?
No, no, no.
Yeah, it is not possible, right? So the ideal generator x is, I mean, so option 2 is out. And option 1 is out because we need to find some non-trivial thing, okay?
Non-trivial. Yes, yes.
Yes, so now option 3 and 4. Now think that is either generated by x cube plus 3 is inside either generated by x square or not.
No, it's this one. X plus one.
Hmm?
Ideal generated by x plus one.
Hmm. So yeah, correct. So either generated by x plus 1 lies inside that, I mean, so this contains either generated by x cube plus 1. Now into the question and we need to check whether it's trivial or non-trivial, okay? So question over x cube plus 3 by x plus 1 by x cube plus 3, okay? Now it is isomorphic to z2x by x plus 1 and this is isomorphic to z2, so it's which is non-trivial, so this is the answer. Do you understand the way?
Yes, yes.
Yeah. So okay, so let's go to the next problem. So is a true false, every integral domain in which every pyramidal is maximum is fit. So it is true or false. In integral domain, if every pyramidal is maximum, there is the fit. It's true or false. Think about it.
It, thinking about
Sorry.
thinking about it.
Yes, yes. Let's take it. mean, first of all, if it is, I mean, just if it is true, then it must be theorem, right? Because it's a very strong result, so it has to be false. So try to get some counter example for this. Okay, try to get some counter examples. I mean, don't think with complicated counterexamples. The counterexample you already, I mean, those these that ring you already have seen many times. Yeah, you in fact have used. Just you need to realize that that ring has to be used. Okay, that is the thing. So don't go with complicated counterexamples. First, think with simple, easy counterexamples. So consider the ring. I mean, the answer is false. And if you consider the ring Z, okay, in this is what the prime ideals. Prime ideals are of the form Pz, and these are the only maps materials, right? So for Z, it is every prime ideal maximum ideal, but it is not a field. I mean, and do you understand? Do you understand? I mean, there is a counter example. That's all. There is nothing more than that. Okay. Let's go to the next question, which tells that true or false. ring of 2 cross 2 upper triangular matrices real entries are isomorphic with 2 cross 2 lower matrices with ring of 2 cross upper triangular matrices with real entries isomorphic to 2 cross lower triangular matrices with real entries. Is it true or false? Now, obviously, I hope you can guess what is the answer. But just tell me or first verify what is the answer. Then please let me know. So what is the answer? Is true or false? Don't hesitate. Please tell the answer. What do you think? True or false? Or please tell. Is it true or false?
True.
True. True.
Yeah. Okay. I mean, it's true in obvious way. So I'm not writing the solution. Okay. Okay. Monitoring the solution. Okay. Just wait. So do you know the field of fraction?
Yes, yes.
Okay. So do you know that if R is a given ring, then what are the elements? I mean, what is the form of the elements of its ring of fraction? Do you know this? Suppose a
Uh,
given ring R is there, and suppose F2 means field of fraction field. Then do you know
yes,
the
yes.
how the elements of look like how? I mean, what is the element of that?
Mm, element A B inverse where A B are from R.
Yes, it's right. Okay. Okay. So this question. So this is the. I mean, so question is, what is the field of fraction at third bracket I? So these are the all elements A plus IB, where AB belongs to Z. Okay. Now the question is, what are the field of fraction of Z third bracket I? Understand what you need to do? You need to find a field of fraction Z third bracket I, or Z third bracket is given plus A plus IB. AB belongs to Z. Okay. So what to do? I mean, what is the how the elements of look like of the fraction field of Zi? Please don't be silent. How the elements of how the elements look like of the fraction field of Zi?
A plus bi by by c minus di.
Why suddenly a minus? Hmm? Why minus?
uh,
Why minus suddenly?
no minus no minus c plus di.
Right. Now, so these are the elements of the form. Now, from this you need to understand how the field of fraction of Zi look like. Okay. Now try to understand. I mean, okay. So the point is that
Quotient group of Z divided by x square plus 1.
sorry. Can you repeat?
Quotient group Z,
Can, what,
quotient field Z divided by
uh,
x square plus 1 generated ideal.
what is x square plus 1? I mean, if we have only I, suddenly where x comes? Hmm? Suddenly from where the x
X,
comes?
x square plus 1 is
X square,
polynomial,
I mean, suddenly from
irreducible.
suddenly what a polynomial is coming. You have only the ring Z. Suddenly what a polynomial is coming. It is, you know that if R is a ring, then its field of fraction is equal to A by B, okay, where B non-zero. So suddenly what the polynomial element is coming. Okay, so the thing is, what suppose is these elements are look like A plus
I
I.
think extension field is Z to Z.
Sorry,
Extension field.
extension field. Okay. So what is the field you are saying? No. First of all, its fraction field is a field, obviously, and it contains the whole ring. I mean, if with the field of fraction of R, then it contains the ring R. Okay. Now the question is, we have a particular form of elements of F. Now we need to determine the F from the given form. Okay, that is the point. Okay, so the thing is that it's the elements of the form A plus I plus C plus I. Okay. Now what we need to do? We need to multiply this thing by conjugate of C plus ID. So this is, so I mean this element belongs to where? This element belongs to Q first bracket I. So the field of fraction of say first bracket I is nothing but Q first bracket I. Do you understand? This we already sorry.
Mhm.
Can you specify? It is already known that if I mean the elements are of the form A plus I plus C plus ID. So you need to uh, multi- multiply numerator denominator by its conjugate C minus ID, and you get this element. Now this element is this belongs to Q third bracket I. So the field of fraction of Z third bracket I is equal to Q third bracket I. That's all it is. Okay, nothing more than that. Understand? You understand?
Yes.
So the next problem is for okay. So uh, okay. So assignment 7, the main problem finished. Okay. So let's go to the assignment 8. Okay, before going to this, let me know, do you have any questions from other parts? Do you have any questions from other parts? Please let me know. Don't hesitate. Oh, so let's start the assignment 8. So, let me open the website. Website is opening suddenly. Oh, first problem is, so we are defining a ring here, the ring of the all continuous functions from R to R, and dr f R to R, set up for differential function. Okay, these are the two things we are defining. Okay, now, and it is known that both are abelian groups with respect to addition. It is well known fact. Okay. Now, for a belongs to R, and for a function f from R to R, by AF we define this A of f. Okay. Now the question is that under this multiplication, is CR is a left term module, and secondly CR is a left term module. Now the question is it true or false? Do you understand the question? What you need to do? It is given that CR and DR. CR is the set of all continuous functions from C to C. A DR of all set of all differential functions from R to R. Okay. Sorry, I mean set of all continuous functions from R to R. Okay. And both are given to abelian with respect to addition. Okay. It is given. Now, uh, yeah. Now we want to know. I mean, also we are giving some extra multiplication by AF defining like this. Okay. Now the question under the extra multiplication, is CR a letter model or is DR a letter model? So the question is it true or false? Okay. So for in order to check it's a model, what you need to do? In order to check something is a module, what you need to do? Please don't be silent.
So, vector addition, scalar multiplication for module.
Yes. So okay. So you need to check certain conditions, right? That is A plus G. You need to check whether it is A plus AG or not. Similarly, A plus BF is equal to AF plus BF is yes or not. Also, AFG is it AFG not? Also, 1 dot n is equal to F. You need to check both these four conditions, right? Whether these are
Yes, sir.
satisfied, right? Now the thing is,
Sir.
it's quite obvious that it is going to be satisfied. So that's why both are left turn module.
Yes, sir. Clear.
So, so another good problem. Suppose R is a ring and M is left R module, okay? And let Z be an element, the center of things. Now we are considering also M dash. All those M belongs to M, Rm equal to 0 for some non-zero R in R. And Zm is equal to Z suffix M, M belongs to. So now the question is, this M dash left R submodule of M, and secondly Zm is left R submodule of M. Now we need to check which one is true or which one is false. So basically what you need to do. So M dash consider those elements which whose sum is 0 for sum, and Zm is given to normal Zm, okay? And Z is the center of the. Now you need to check whether M dash is the submodule or Zm is a left submodule. You need to check this. So what you need to check that. So what are the conditions of some subset being a submodule? I mean, what are the characterization? I mean, what is the if and only criterion? Tell what is the if and only criteria?
The second one is submodel.
Okay. Okay. Before that, tell me what is the if and only criteria for a subset being a submodule? What is the equivalent criteria for this? So equivalent criteria of it is that suppose m dash sub 7, okay, then m dash is an submodule of m if and only for any m1 m2 belongs to m prime and lambda mu belongs to the vector space, like vector space like here. This addition belongs to m dash. If this holds, then m dash will be a submodule. Okay. Now the thing is, we need to check whether these two are being satisfied for the one or two, right? So now obviously you should tell which one is true and which one is false.
Second one is true, sir.
Yeah, and first one. And first one may not be ideal. Sorry, submodule. So for that you need to construct some examples. That's all it is. Anyway, so that's what it is. So there is nothing much to do. So now, consider the matrix and consider the linear transformation given by A. P goes to H. Okay, and let R be the ring by R third. Then it is known that R to the power 4 Pn gives a left armored structure on R4. Okay. Now the question is, which of the following is submodule? Full R4 or x0 y0 xy belongs to R 0 x0 y xy belongs to R x y z 0 x y z belongs to R. Okay, so first let me explain the question. A is given to be the matrix, okay, and we have some linear transformation. Now first tell me, do you understand the what does it mean by sorry, you understand what does it mean by R4, TA gives the left armored structure on RX. R to the 4. Do you know what does it mean? Do you know what does it mean?
No.
Yes or no? What do you say? So this means like, so first problem is what is the R model structure? Okay. So basically Rx cross R4 to R4 is defined as X comma some R4 some element is called it P defined to be TP. Okay. And since we are giving it a model structure, so basically a polynomial like a0 a1x plus daughter a n x to the power n dot b is defined as uh, a0 v a1 t v a2 t square v plus dot an t to the power n. This is the R model structure. This is R to the power Rx model structure on R4 induced by the linear map TA. Okay. Now the question under this operation, I mean under this model structure, which of the one of the following are the submodules? So this is what you need to understand. I mean, do you understand what to do? So this is the R4 model is R model R model structure. R4 now you need to check which under this condition which one of the four are the submodules R4. That is what we need to do. Nothing more than that. Understand? Okay, I hope you understand what I'm trying to say. So the thing is, okay, you try in your home this problem. If you could not solve it, please let me know in the next week. Okay, I will solve it for you. Okay, so one second. Okay, so let's so for now today let's stop here. If you have any doubt, please ask in the next session. Okay, so thank you. I am leaving the call.
Thank you, sir.